Hello students, welcome you all again to this video lecture series on chapter mechanical testing of metals. In last lecture we have seen just started what is impact test and what is impact and impact force. We have seen why this impact test is necessary and what are the types of materials that can be impact tested and what is the generalized procedure for carrying out this impact testing. Then we have seen there are the two kind of testing methods. First is Charpy test method and second is ISOT test method. So these two tests are for carrying out this impact test, and the result of these both impact test will be same. That is, we are finding through these two methods same thing, that is a toughness and impact energy. So we will see in detail now in this video Charpy test in detail. So let us start. The Charpy impact test is also known as a Charpy V-notch test, and it is a standardized test specimen will be there which determines the amount of energy absorbed by the material during the fracture. During fracture, whatever the amount of energy absorbed, that amount of energy is nothing but a toughness that we can find out through this Charpy V-notch test. This absorbed energy is the measure of a given material's notch toughness and act as a tools to study. So this is nothing but a toughness. So it is a widely applied in industry since it is easy to prepare and conduct and results can be obtained quickly and cheaply. This method is preferred in many industries. Charpy test. So in Charpy test, the standard test specimen is prepared with the sizes as shown in the figure or as written there. 55 mm by 10 mm by 10 mm test specimen is taken. Any kind of material with a 55 mm length and a cross sectional area of 10 mm by 10 mm is taken, and one notch is prepared exactly at the middle of the specimen with the 2 mm deep and a 45-degree angle in notch. So the notch may be V notch or U notch. If it is a V notch having 2 mm deep with a 45-degree angle, and radius at that 45-degree angle will be 0.25 mm along with the base. So in that diagram also you can observe here length 55 mm, cross sectional area 10 mm by 10 mm, and that notch at exactly center with the 45-degree angle, and radius of the base of that notch is 0.25 mm. That radius we have taken for that V notch. For U notch, generally a notch is prepared with the 5 mm deep notch and with the 1 mm radius at the base of the notch. This is if U notch is prepared. Generally for Charpy test you can prefer V notch or U notch. Two types of notches can be made for the Charpy test. So this is a standard specimen taken for the Charpy test. Now we will just quickly revise this procedure to carry it out for the Charpy test. In last video also we have seen this procedure. Firstly, we will prepare the test specimen with the standard size as shown in this diagram. We'll firstly prepare this standard test specimen with 55 mm length, 10 mm by 10 mm cross section, and one V notch with the 45-degree angle and base radius as a 0.25 mm. Secondly, we will place that sample in the position just like in this diagram you can observe. It is placed like a cantilever beam with the notch facing in opposite direction of hammer. So this is the placing position of that test specimen in the Charpy V notch test. Thirdly, we'll record the initial reading. Thirdly, we will record the initial readings shown in the pointer scale. Then we will move that pendulum to the certain height h1 and we will release from that height so that that hammer will hit onto the specimen and that specimen will get break, and after breaking that specimen that hammer will again go to the certain height because it is a pendulum. It will go to the certain height. We will again measure that height as h2. So we have got two heights h1 and h2, and we have also got a reading on that pointer. So we'll record all the readings, two heights and that reading on the pointer. So this is the test procedure to be carried out, simple test procedure. With the help of hammer we have to break the test specimen. Now specimen is set like a simply supported beam as shown in this diagram also, with the V notch in opposite direction of the hammer. Wherever hammer hits to that specimen, it will be in opposite direction of V notch. So here also you can observe that height, initial height we have represented by H0, final height after breaking that specimen is represented by Hx. So these two heights are there, and in this diagram you can observe the hammer hits to the uh, simply supported specimen in opposite direction of the notch. This is a hammer and this is a V notch. So this is a Charpy V notch test. So after hitting we can find out two things, that is the impact energy and toughness of that test specimen. Whatever may be the material of the specimen, we can find out these two things, impact energy and toughness of the material. So how to find out impact energy by this Charpy V notch test? So initially we have taken the reading of initial height h. So see in that diagrams, suppose we have lifted that hammer in the left side by distance h, capital H, and then we have released from that height, and that test specimen is exactly at the center. It will break the test specimen and it will move to the height small h. So these two readings we have taken, capital H and small h. So initial energy in that potential energy we can give by mgh, small m that is the mass of that hammer, g is acceleration due to gravity, that can be given by 9.81 meter per second square, and capital H is the height initially we have measured. So initial height, so mgh will be the initial potential energy. After hitting we will got the small h height of that pendulum or hammer. So there we can find out the final potential energy. E is equal to mg small h. M is mass of that hammer or pendulum, g is acceleration due to gravity, and small h is the height after hitting that specimen or after breaking the specimen. So there you have got difference between the two energies, initial potential energy and final potential energy, and this difference in the energy is given to the specimen so that specimen will get break, and that difference in energy will give you the impact energy. That much amount of impact energy is required to break your specimen of this material. So that you can find out from this Charpy test, Charpy impact test. Also you can find out the toughness of the material. So how toughness is found? Toughness can be found by one simple formula, that is impact energy, whatever you have now found just now, impact energy divided by area of the specimen. So that area of the specimen, cross sectional area, if you divide it to the impact energy, you will get the toughness of that energy. So by these two simple calculations you will get the impact energy as well as the toughness of the material by Charpy V notch impact test. So this is Charpy test. In next video we will see the ISOT test as well as we will see the demonstration of both these methods.